And for this operation we have a couple of tools. Dial indicator is going to go on a magnetic base. I have another dial indicator on a magnet that we're going to use for taking our cuts. I've got a snap gauge for measuring internal diameters. And I've got a set of micrometers here. Okay, good. If anything, we want it a little bit under. And that
it is just a touch under.
Good, perfect. We can always adjust that depending on our cutting speeds and the material and how it cuts. We can check using a center, making sure that the boring bar is at the same height. And because the pipe is uneven, we want to take a cut off the outside here. And this is one of the disadvantages of having a piece being held out so far, is because the jaws will only grab so much that it's sort of an unsafe setup. So forgive me for this, but what I'm doing is preparing it for a steady rest. And what I'm going to watch for is to make sure it doesn't move, doesn't come out of alignment. And I'm just going to take a light cut off the outside. I've got slow RPM to reduce the vibration because I want a smooth finish, because my steady rest has got roller bearings on it. And if it's not a smooth finish, it's going to screw it up. So you can see it's a bit of an intermittent cut. I'm probably going to take 2 cuts before it finishes. I'm not so concerned about the outside diameter on this pipe, but what we want to do is get a good cleanup, and I think I'm going to have to take 1 more cut. Before I continue on, I think I'm going to turn the front face and turn the outside of that for the first 1.5 inches also. What I'm going to have to do is flip this around and set it up in the chuck, and I want to move it out, so that's just one of the things I think I'm going to do. So I've got a bit of rust on the surface here still, and that's going to adversely affect the roller. So I'm going to take 1 more cut, but I think what I'll do is I'll take a cut from the front of this and see if it'll carry through. I'm hoping it doesn't move on me. If it does, I'm going to have to reset it up. But I have a pretty good surface here to do that. What I'm hoping to do is to set this up so I can face it, and this will allow me to do that as a safe operation, or a safer operation. We run a big risk anytime we have a piece extended out. The rule always is to hold it out as little as possible. But I cannot stuff this into the chuck because the size of the machine doesn't allow me that. It doesn't have a spindle hole big enough to accept the full diameter of the pipe. So this is a compromise. But this is one way of approaching it in a way that is safer. Now I'm going to take 1 final cut just to remove the last bit of rust off here. And Keaton has brought me some oil here. I'm just put a couple drops on here, and it should improve the surface finish. You can hear a difference. I've got a combination of real light cut, but the lubrication is improving the surface finish, which is good because we're running bearings on here afterwards. So we'll let this cut run all the way up, and then I'll set up the steady rest. I'm just going to finish my cut up here, and it looks like I've got a pretty good surface, something we can work with. So I'll stop my cut, pull my tool back, I'm going to bring my machine back to a halt. I've still got a little bit of rust here, but we're just going to ignore that. I'll make sure there's no particles on here. Now, Keaton's going to bring the steady rest over, but before that happens, I want to clean my area. This is our newest machine, and I want to make sure that when I put the steady rest on the bed that there's no metal fragments under there. Okay, thanks Keaton. So I'm just going to tighten down the steady rest. I've got it back a couple inches here. And that's secure. And now I'm just going to gently approach the rollers, making sure they're clean. And just touch them lightly against my workpiece. just a little bit here. Once I've got that set up and locked into place. Now we have full support, and that allows us to be able to do most machining operations without worry of it moving on us. Now what we're trying to do here is we're going to take a cut out of the inside. We want to remove the seam. This is going to slip over another piece of pipe. So we've got our boring bar set up here at the proper height. And first of all, what we have to do, because this was cut in the saw, we want to take a cut and face it, chamfer we're chamfer the outside, and we're also going to then bore it out. And the final process will be chamfering that inside edge. So flip and rotate my tool post over here. We could probably face with this. So I've got my RPM still the same, and I'm going to face it. It's an intermittent cut because of the saw. So we're going to take light cuts at the beginning. And I've got an insert tool here that I'm going to use for this, and we'll switch over to the boring bar later. One thing I'm concerned about is my chips falling into the rollers of my steady rest, because it will leave a horrible mark here. So that's why I set up with my my rollers all the way back. This one's not rolling, so I'm just going to tighten it up a bit, make sure there's even pressure on that. And I'm almost done here. There's my full cut. Nice smooth finish. Check, and I think I'll just take one bit more. There's a bit of saw mark still on the other side here. Final cut. Good. Now, before I switch here, I'm going to rotate my tool post, move my next tool into location, which will allow me to cut. This will allow me to cut the chamfer on the outside edge here, because I don't want any sharp edges. Turn the nose of the tool at a 45, and I'm just going to touch it in here. Good, or the 16th of an inch. Now that sets me up for boring. I'm going to rotate that into position and lock the toolbar here. I'm just going to run it through here to the very end. Make sure I've got enough clearance so that it comes to the very end. And I see I've got interference with my tool post, so I'm going to pull out my tool bit here. Always got to make sure there's not any interference as you have your feed running. And I'm looking through the side here on the end and visualizing, and I can see the tip of my tool post. I'm going to grab a felt pen, put a little mark there. I'm also going to be listening, and I'm also going to be able to determine by the sound of it. Now I'm ready to do my first cut on this. So you can see I've got a bit of vibration. To reduce vibration, lower the speed or increase the feed. I'm going to start by lowering the feed rate. Concerns we have with a boring bar, even though this is a big heavy duty boring bar, is that we may encounter vibration. So I may have to adjust my speeds and feeds depending on what I encounter. The thinner the wall, the more likely it is to vibrate. And pipe is generally really a gummy material. It doesn't like to cut as much as mild steel. So we may encounter problems with this. The first cut I'm going to take will be to remove the seam, just the high spot. And we'll start that. I'm getting a bit of toolbar flex, but by putting my hand on here, that'll reduce some of the vibration. I'm hoping that once I get that high spot out, that my vibration problems will go away a little bit. And I like to use a dial indicator on my machines to show my depth of cut. Keaton was good enough to finish machining this for me. Now he's going to, because we bored it right through, he's going to cut the corners, flip it around, and gently cut the inside and the outside of the other side without using the steady. So he'll do the cleanup.